Hey, yeah, welcome back. So today we're reviewing Unit 3, which is all about these linear function problems that are either in the CLEP style or the kinds of problems you might see on the TSI A2 test. So let's get into it. Number 1 says the shaded region in the figure represents the intersection of the graphs of x is greater than or equal to 0, y is greater than or equal to 0, and which of the following inequalities? The first thing is to identify which line you're actually looking for. X is greater than 0 is going to be a vertical line, which I'll show you here. It's going to be this vertical line that basically is the y-axis. And since it says x is greater than or equal to 0, we should be shading to the right. So I'm just going to draw a little arrow here to show that we're shading to the right. Y is greater than or equal to 0 is this horizontal line where y equals 0. Since it's greater than, we're going to shade up. And then the last inequality that is bordering the shaded region is this, this red line you see pictured here. So that's really the one we're looking for. One thing you might notice is that the shading here is down. Okay, so the fact that we have a solid line and that we're shading down, that tells you that the inequality symbol we're going to use is less than or equal to. So once you establish that, then it's just a matter of coming up with the slope and the y-intercept of that line. So for the slope, you can pick any 2 points on the line that you want. I'm going to go ahead and say pick this y-intercept here. That is not a circle. Let's try that again. We're going to pick this point right here. And then I guess I'll just pick this point here. And you can see that in order to get from one point to the next, and you always read these graphs from left to right, go down 3 to the right 2. And that's why our slope is negative 3 over 2. It's negative because it's going down for left to right. And then you see the 3 is your change in y, and 2 is the change in x. That pattern should stay consistent because it's a linear function. So the slope is negative 3 over 2. And then we can identify the y-intercept right here. So if we're writing our equation in that y equals mx plus b format, the m, or the slope, is going to be the negative 3/2, and then the b, or the y-intercept, is 3. So our answer here is going to be D. Number 2 says the graph of the line with this equation is shown. Which of the following must be true? So there's really 2 things you need to look at on this line. Notice there's no numbers labeled anywhere, so unfortunately we're not going to be able to use any values to help us answer this. But what we can say is that notice here that the y-intercept is negative. That's going to be important. Then also the fact that we're going up to the right means that we have a positive slope. So those 2 pieces of information are really what we need. The fact that we have a negative y-intercept and a positive slope. So the given equation right here is given in standard form, and which is not really particularly useful to us. We want to put this into slope-intercept form so that we can make a connection between the a and the b and the slope and the y-intercept. So to do that, the first thing you'd want to do is you'd want to subtract ax from both sides. And what that's going to do is move this ax term from here over to the right-hand side, but since we're subtracting, it'll be negative. And then after that, we'll have by equals negative ax plus 1. So we can divide both sides by b and end up with this equation here. Right, this negative a over bx plus 1 over b. So when we're looking at this equation, this is in slope-intercept form, that mx plus b form. So this term right here, not have a filled-in circle there, this term right here represents the y-intercept, 1 over b. Now we don't have any scale on here to know exactly what b is going to be, but since the y-intercept is negative, that means this number must be negative. And so since b is the only variable in this ratio, b has to be negative. So that means that b is going to be less than 0, which means it's not going to be this answer, it's not going to be D, and it can't be E either. So it's got to be A or C. This is the only 2 that's showing negative b value. And so now comes the hard part, which is determining A. I mean, really, I think if you go wrong, it's probably going to be because you just get lost with all the negatives here. So we've got this coefficient of x, right? Negative a over b. That is our slope. and the slope must be positive. So if we have a negative b value right here, then we don't know, like I said, we don't have any numbers here. Let's say it was like -2. Okay, we don't know what it is, but we'll just say -2 just for the sake of argument here. So if it was -2, notice here how we have already a negative in front. That's from this negative ax. Then the denominator is negative as well. We have two negatives in this fraction. Those will cancel each other out and make the whole thing positive, which is what we want, right? This line has a positive slope, which means that a has to be positive. If a was negative, then we'd have a negative divided by a negative, which is positive, and then this third negative out here would make the whole thing negative again. So really, if you want the slope to be positive, you need either everything to be positive or two negatives to cancel out and make a positive. But if you want the slope to be negative, if you saw a similar problem here, then you'd want either 1 or 3 negative signs here. So because the slope is positive here, and these two negatives essentially cancel each other out, that means that a has got to be positive. I'm going to bring this back, call this b. But yeah, so a must be positive, and so our answer here. Number 3 says, which quadrants of the xy plane contain points of this graph? And so here I think it's just easier, just like with the last problem, to go ahead and put this into slope-intercept form. And to do that, you would subtract 6x from both sides, and then divide both sides by -3. Now check this out. Notice here the inequality symbol flipped signs from greater than or to less than. The reason for that is because we are dividing both sides by a negative. Anytime you multiply or divide both sides by a negative number, you do have to flip the inequality sign. So once we do that, we get y is less than 2x minus 3. So we're going to plot that by first plotting the y-intercept at -3, and then using the slope of 2 to go up 2 over 1, up 2 over 1, up 2 over 1, and then just kind of connect the dots. Notice here I have a dotted line, and that's because it doesn't say less than or equal to. If I had the equal to, then I would make this solid, but it doesn't have that, so dotted is the way to go. What that indicates is that the points on that line are not solutions to the inequality. Now, since it's less than, we're going to shade down to show where all the solutions do lie, which is going to be below the line. And we can see we have shaded regions, or I don't want to say this. We have shaded. Well, we have solutions to the solutions. Sorry, we have solutions to the inequality in quadrants 1, 3. We see a little bit there, and 4. If I continued this down, we'd have way more solutions in quadrant 3, but we only see like a little sliver of it. But what we can say with certainty is that there are no solutions in quadrant 2. So the quadrants 1, 3, and 4 would be the ones that have solutions to the inequality, which are represented by these points on the graph. Number 4 says Weston invests $2,000 and at the same time Cora invests $1,000. The value of Weston's investment decreases. Okay, so that means it goes down. We're going to subtract $100 per year, while the value of Cora's investment increases by $200 per year. Increasing add. So at this point, we're just trying to write an equation, two equations actually, one equation for Weston's investment and then one for Cora's. So since Weston started with $2,000 and the investment decreases by $100 per year, we're going to have $2,000 minus the $100 per year. Cora's investment started at $1,000 and is increasing by $200 per year. So that's why here the answer is C. There's nothing really algebraic that you need to do for this problem. You don't have to solve anything. All you have to be able to do is interpret the word problem and write the equations that could be used to model the scenario. Number 5 is probably the most algebraic, heavy question on here. There's a little bit of algebra that you need. It says, which of the following is an equation of a line that passes through these 2 points in the xy plane? So first thing we need to do is find the slope. We're going to find the slope by finding the change in y over change in x. And we can see that my change in y, or my delta y, to go from 4 to 3 is -1. Right? We subtract 1 to go from 4 to 3. And to get from -3 to 4, we've got to add 7. So my slope is going to be -1 over 7, which is -1/7. Then we can use point slope form, which is given here, to substitute in the slope and one of the points. And then we can rewrite it in standard form. So notice here I chose 4, 3 for my x1, y1, but you could just as easily choose -3, 4. And although this step is going to look a little different, you'd have y plus 4 here and have y minus 4 here, and you'd have x plus 3 here. Once you simplify everything and manipulate it into standard form, you'll see you get the same answer. So it doesn't really matter which point you pick. I just tend to pick the point that has fewer negatives if I have an option. So anyway, this is going to be my x1, y1. My slope is m. I plug in those 3 values. Slope. Here's the x1, the 4, the y1, the 3. And then I have it in point slope form. But what I'm trying to do is write this in standard form. So first I'm going to use the distributive property to multiply -1/7 by x and also by -4. And that's going to give me this -1/7 x plus 4/7 here. Now you have a couple options on the next step. Ultimately, what we want to do is collect all the x terms and y terms on one side and the constant on the other side. But notice none of our answer choices have any fractions. So at some point, we're going to have to clear those fractions. We do that by multiplying both sides of the equation by whatever the least common multiple of all the fractions is. Now, here we only have sevenths, so we would multiply both sides by sevenths to accomplish that. So you could do it here. You could add 3 first and then clear the fractions, but I just found it easier to go ahead and multiply both of these sides by 7 up front. That way, I just wouldn't have to worry about dealing with fractions after this. If I distribute the 7 here, I get 7y minus 21. And if I distribute the 7 here, I get -1x plus 4. So it just clears those fractions out. Then I have this. So I still need to move a couple things around to get it to look like what I'm trying to make this, to get this equation into standard form. And so what I'm going to do is first add x to move that over to the left. And then I'm going to add 21 and move this to the right. So first the add x to both sides moves the x to the left-hand side. Then I want to add 21 to both sides to move this constant to the right. 4 plus 21 is 25. So our answer here is B. Number 6. This is probably the other problem that requires the most algebra. First thing you have to do is write both of these equations. And it says a paper company has budgeted $1,400 for the purchase of 11 printers. The 11 printers are chosen from 2 models, Model X and Model Y. If a Model X printer costs $100 and a Model Y printer costs $150, how many Model X printers should the company purchase to use exactly the budgeted money? So there's 2 equations that you're going to start with. They're right here. The first one has to do with how many printers that you are buying. And that says, the problem says we have a total of 11. So if I add all the Model X printers to all the Y printers, the number of these should add up to 11. The other piece of information is about the cost. Printer X costs $100 and printer Y costs $150. So my other equation is going to be $100 times how many Model X's, so times X, plus $150 per Model Y, so 150 times Y. And the total amount of money I'm trying to spend is $1,400. So you're going to start with these 2 equations. Then we're going to use a method called substitution to solve this system of equation. We don't have to solve it all the way because we don't really care how many Model Y printers we need to buy. We only care about the X's. So we're not going to go through the entire process of solving the system, but we will go far enough to get X. The way we do that is first you want to isolate y in one of the 2 equations, and I just found it easier to isolate y in the first equation because all you have to do is just subtract x and get 11 minus x. It'd be a little bit more work to get y isolated on this, but you could if you wanted to. Once once I have y set up like this, where y equals 11 minus x, I'm going to replace y with 11 minus x right here. And so that's what I have written here. 100x plus 150 times 11 minus x equals 1400. Once you have that equation set up, really, as long as you're following the proper steps of solving a linear equation, it's going to be tough to get this one wrong with a calculator. But let me walk you through the steps here. First, you would distribute this 150. So you would do 150 times 11, which is 1650, and 150 times negative x, which is negative 150. Then I combine like terms, 100x minus 150x, and that gave me negative 50x. Then I'm going to subtract 1,650 from both sides. And so 1,400 minus 1650 is going to give me this negative 250. So that's where that's coming from. And then finally, dividing both sides by negative 50 is going to give me x equals 5, which is the number of Model X printers the company should buy. Now, just as a side note, it doesn't ask for the Model Y printers, but if it did, all you'd have to do is just go back up to this original equation, say, okay, well, 5 plus what number is 11, and hopefully you can figure out pretty quickly that'd be 6. Once you do that, or if you do that, you can use that information to test out the second equation and get that one right. So anyway, that's how you do number 6. For number 7, it says in the xy plane, what's the x-intercept of this equation? So usually, this equation's set up in slope-intercept form. So if it were to ask for the y-intercept, we could answer that way easier. It's just going to be whatever the constant is, in this case, negative 6. But it's asking for the x-intercept. And the x-intercept occurs where y equals 0. So to get the x-intercept, we need to change y to 0, or substitute 0 in for y, and then solve for x. We could do that in 2 steps. We'll have a calculator that can handle fractions, so don't be afraid to use that function. First, we'll add 6 to both sides to get 6 equals negative 3/8x, and then we could just divide both sides by negative 3/8 and get x equals negative 16. So the x-intercept is at negative 16 comma 0. The way the test is set up, you would just type in the negative 16. I believe that's how the CLEP test will have it as well. But, for our class, if you do negative 16 comma 0, I'm not obviously going to mark that wrong. That would be correct. Number 8 says in the xy plane, the line given by which of the following is perpendicular to the line 3x minus 4y equals 5. So perpendicular lines are lines that intersect at a 90-degree angle, and their relationship, the relationship between their slopes is that they are opposite reciprocals. So what I mean when I say that is, first, they're opposites, meaning one's positive and one's negative. And then reciprocals are fractions that have been flipped. So if you have something like 2/3, the reciprocal would be 3/2. So if they're opposite reciprocals, if we know the slope of the line that we're trying to find the perpendicular one for, we just need to flip that fraction, slap on a negative sign, and then we'll know what to find. So before we can really do anything, we need to know what the slope of the original equation is. And we can do that by putting this standard form equation into slope-intercept form. Hopefully you're noticing that there's a lot of problems where you have to do that. So hopefully you're practicing this process of isolating y. So the first thing to do would be to subtract 3x from both sides. And so that'll give me negative 4y equals negative 3x plus 5. And then you want to divide both sides by negative 4, which is what you get here. So after I divide negative 3 by negative 4, I get positive 3/4. And then we don't really care about the y-intercept, but it would be negative 5. So the slope of this line is 3/4, which means the slope of the perpendicular line needs to be negative 4/3. Remember, opposite, so it's got to be negative, and then reciprocal, flip the fraction. And so there's not really like a shortcut here that I would recommend. Maybe I just haven't thought of one yet, but I think the way to go here is just to go starting with A and put them into slope-intercept form and find their slope and keep going until you find the right one. So this one kind of works out to where the first one has a slope of negative 4/3. I really wouldn't need to go any further, but I did make a note of what the slopes of these other lines were, just so you could see that none of them are the same. But you would find that slope by doing the same thing we did to find the slope of this one, which is to rewrite it in slope intercept. So the answer to number 8 is going to be A. Number 9 says the owner of a small restaurant earned a profit of $750 during the month of operation. And I've created a table here, and you can see that. For month 1, $750. As according to the business model for the next 12 months, it's projected that the profit for each month after the first will be $100 more than the profit of the preceding. So notice month 2 would be $850, 3 would be $950. Which, where were we? If P of M represents the profit for each month M, and M equals 1 represents the first month, which of the following functions describes the business model? So what's tricky about this is the vast majority of students that I see work this problem out will select D. They've got the slope correct because we are adding $100 every month, but they got the y-intercept wrong. And to figure out what the y-intercept actually is, you have to think back to what a y-intercept is, right? So the y-intercept is that point where the graph crosses the x-axis, and this happens when x is 0, or in this case, when m is 0. This is not going to be a given point, so you can just work your way backwards in the table to figure out what it would be, and it would be 650. So our answer here would be C. Number 10 says Sawyer was thirsty, so he poured a glass of water into an empty glass. Poured the water slowly at first, then faster, then slowly again. Which of the following graphs could be a model for the height of the water? Okay, so the answer here is B. There's no like arithmetic or algebra to do here. You just have to think about what the slope or the rate of change of the graph would have to look like given these conditions. So him pouring the water slowly is going to have a smaller rate of change, or a less steep slope, than if he pours it faster. If you pour a glass faster, the height of the water in the glass is going to raise more quickly, which is why you're seeing this larger rate of change here. And then finally, when he slows down, it kind of levels off a little bit more. You can see the difference between this one and C, where C has the larger rate of change at the beginning and the end, and a slower rate of change at the middle. So if this problem was any different, like if it said he started pouring quickly, then slowed down, then started pouring quickly again, then it would be C. A would have to be like a consistent pour, but notice how A starts not at the origin, but up here. What would have to be true about this is the cup would have to already have some water in it. So maybe his cup's halfway full and he starts to pour it up to just kind of top himself off there. E would start with an empty cup, but have a consistent pour here. And then D is kind of the fun one, because at this point here where the height goes back down, something would have to happen. So either he drank the water, or he knocked over the glass, or something happened to where the height of the water decreased. So really the only one that makes sense here is number 11. Says last year a supermarket sold B cereal boxes. So notice here I made 3 notes here. I made a note like, how are we describing last year, the number of boxes sold last year? It would just be B. Last year a supermarket sold B. Then this year the supermarket sold 7 more than twice the number of cereal boxes sold last year. So last year was B, but if it's 7 more than twice what they sold last year, the way you would represent that is 2B plus 7. Then it says, if next year the supermarket plans on selling twice the number of cereal boxes that sold this year, how many cereal boxes does the supermarket expect to sell next year? So if we're going to double this year, next year, that sounds a little confusing. If we take the number of boxes we sold this year and we double it, what that means is we are going to, or twice the number, we're going to multiply it by 2. So what you have to do is take the whole expression that represents this year and multiply it by 2. So once you realize that, like, the algebra is not really that hard here. It's just a matter of making sure you're keeping track of how many boxes were sold in which year. And so next year, if we actually distribute this 2, we'll get 4B plus 14. So our answer is 11. Number 12 says if 3W minus 4 equals 15, what's the value of W? Starting with number 11, we're working more at these TSI style problems, less the CLEP. And what you'll probably notice is that these are a little easier. This one's very straightforward. It's just a solve for, in this case, usually solve for x, but in this case, solve for w kind of problem. So you just have this linear equation that, well, you have to know your properties of equality to be able to solve. So first we would add 4 to both sides. That would make this 15 and 19, get rid of the 4 over here. And then we would divide both sides by 3 to get 19 over 3, and that's really it. Okay, so it's just solving a two-step linear equation. Nothing too crazy. You don't even have to estimate this or anything like that. Just make sure you're following the linear solving process throughout for that problem. For D, says if 13n minus 18 equals 4n, what's the value of 12n? Well, here we've got this equation that we need to solve first. We need to find what the value of n is. So if 13n minus 18 equals 4n, I can subtract 4n from both sides to, in effect, combine my like terms there. Now I'm left with a two-step equation, kind of like number 12, the problem we just did. I would add 18 here. See, now we have 9n equals 18. Then finally divide both sides by 9 to get n equals 2. Now the question is not asking what is n, though you do need to know what that is, but it's asking what 12 times n is. So if n is 2, then 12 times n would be 12 times 2, which is 24, and so the answer is. Number 14 says in the xy plane, the slope of the line y equals mx minus 7 is more than the slope of the line of y equals x minus 7. Which of the following must be true about m? Well, in this equation over here, y equals x, that out of there. Y equals x minus 7. You don't see a number in front of the x, and that's where you typically find the slope. If it's in that mx plus b form, when you do not see a number in front of a variable, there is an assumed 1. So we can say that the slope of this line is 1, or the slope of this line is unknown, but we'll call it m. We have a little letter there to represent that slope. And it says the slope of this first line is more than, okay, so we can use the greater than symbol, the slope of this. So really you just have to read and sort of translate this into an algebraic statement. If the slope here is m, slope here is 1, and the slope of this one's more than the slope of this one, that means m has got to be greater than 1. Here's b. Really, if you solve a similar problem to this, make sure you're looking closely at this phrase. If it said less than, you would use the less than symbol. If you said equal to, you have the equal to symbol. If it said it was perpendicular, then it would be -1, right? It'd be the opposite reciprocal of that. But in this case, it just says more than, so our answer is B. That brings us to our last problem, which is if n had 3 consecutive odd integers, which of the following represents the sum of the 3 integers? Well, if the smallest one is n, so think of your odd integers, right? Your odd integers are all the integers that are not divisible by 2. So we have like 1, we've got 3, we've got 5, 7, 9, 11, 13, 15, 17, etc. I'm not going to go much further than that. And so notice here that each number in this list is 2 more than the previous number. So if the smallest odd integer or the least odd integer is n, and that part is given in the problem here, it says if n is the least of the 3 consecutive odd integers, if n is the least, then the next odd integer would be n plus 2. Notice here, to get to the next number, you got to add 2. For the third odd integer, the third consecutive odd integer, you'd have to add 4. Like, for instance, if 3 was the smallest, 3 plus 2 is 5, 3 plus 4 is 7. The next odd integer would be n plus 4. If it asked for the fourth one, you'd have n plus 6, right? 3 plus 6 is 9. 3 plus 8 is 11, and so on and so forth. So if we have these 3 integers, n, n plus 2, and n plus 4, n plus 2, n plus 4, and we're looking for the sum of those integers, we need to add them up. Whenever we see the word sum, that's the answer to an addition problem. And to add these up, all you really have to do is just combine your like terms. So notice how we've got n plus n plus n. It gives us 3n. And we have 2 plus 4 is 6. So our answer here is 3n plus 6, which is D. And that's the last problem. You can expect the test to be very similar to this review. As always, please reach out and let me know if you guys have any questions. Thanks for watching, and y'all have a great day.